Hello everyone, welcome back to VersaTube. So today I am going to explain all about Newton's law of cooling. This is for 10 marks in ODVC subject. So it is very important in your semester and examination point of view. So let's have a look at it here with a question and a solution now. The temperature of a cup of a coffee is 92 degrees centigrade. So here the temperature of the cup will be taken as theta. Theta equal to 72 degrees. No, 92 degrees. Just a small mistake in pronunciation. So here next, when freshly poured, the room temperature being 24 degrees centigrade. So theta naught equal to room or surrounding temperature. Room temperature or surrounding temperature. It can be named as surrounding temperature. So here we have the formula that theta equal to theta naught plus theta 1 minus theta naught e power minus kt. So this is a formula. So here generally everyone will take C, but for short trick I am taking theta 1 minus theta naught. So let's have a look at it. So first we should find C. C equal to what? Let's find out it. So theta equal to what here? 92 degrees centigrade. 92 equal to theta naught. Theta naught equal to 24 degrees centigrade. 24 plus C. C is what here? C is nothing known. So next, theta minus theta naught is theta 1 is not known, but so we will directly find it out. Theta naught, theta 1 we should find it out, so we write it theta naught here. So here theta 1 minus 24 degrees centigrade into e power minus kt. E power minus kt is what here? E power minus kt is e power minus kt is what? So here temperature at the beginning is what here? Temperature at the beginning is always, temperature at the beginning is 92 degrees centigrade, but at the time t equal to time here, not temperature. So t equal to 0, e power minus 0 or e power 0 equal to what here? 1. So we will take directly 92 degrees equal to 24 degrees plus theta 1 minus 24 degrees centigrade. This will be cancelled out. Theta 1 equal to 92 degrees centigrade. So theta 1 equal to 92 degrees centigrade. So next we should find what here? Next we should find what is given. In 1 minute it was cooled to 80 degrees centigrade. So in 1 minute means what here? 1 minute equal to 60 seconds, or we can directly take 1, because by taking in seconds it will be longer and the calculation is little bit complex, so we'll take directly 1 minute equal to 1. So yeah, by using the same formula, theta equal to how long a period must elapse before the temperature of a cup becomes 65 degrees centigrade. So yeah, in 1 minute, so C theta 1 will be always 90 degrees centigrade. So here theta 1, we should find theta. No, theta equal to theta 1 for case 1. For case 2, theta equal to theta naught. Theta naught is what here? 24 degrees centigrade plus theta 1. Theta 1 minus theta naught is what here? Theta 1 is 92 degrees centigrade. 92 minus 24. 92 minus 24 is what here? 68. That is only now. It's 68 degrees centigrade. So 68 into this is C, or C equal to theta 1 minus theta naught. It's short trick, you can use it, or you can directly calculate it by using C equal to. You can put it both the ways. It is easy for taking theta 1 minus theta naught, as it by doing more problems like this you will get to know that this type of problem solving is better in solving the problems. This method is so better than that. So I am using this method 68 e power minus kt. So k is we should find now. For second case we should find k, and k t equal to what here? 1. So here theta is what here? Theta is 80 degrees. So 80 degrees minus 24 plus 68 equal to 80 minus 24. This will come to this side. 80 minus 24 equal to 68 into e power minus k. So 80 minus 24 is what here? 80 minus 24 is 56. 56 equal to 68 e power minus k. So here you will get by dividing it to 2 2s are 2 8s are 16. 2 3s are 2 4s are. Next again 2 1s are 2 4s are 2 1s are 2 7s are. So 14 by e power minus k equal to 14 by 17. K equal to, by applying this sending to that side, it will become log 14 by 17. So next this minus will be sent to this side, and afterwards it will become, I will do in the next page. Follow it. So here it's minus k equal to log of 14 by 17. So this will make this inverse as k equal to minus log 14 by 17. So you will have the formula m log a equal to log a power m. This formula you should use. K equal to log of this inverse of this, what it will be 17 by 14. So this is the k value. Next we should find what we will find how long in 1 minute it was cooled to 80 degrees. This is the second case or second property of the given question. So how long a period must elapse before the temperature of a cup becomes 65 degrees centigrade? So for 65 degrees centigrade, what will be the time elapsed they are asking. So here same formula, theta equal to theta naught plus theta 1 minus theta naught e power minus kt. T is the time we should find. Theta equal to, here what it will be, it has been given 65 degrees centigrade. So write here 65 degrees centigrade equal to theta naught. Theta naught equal to what here? Theta naught equal to 24 degrees centigrade plus theta 1. Theta 1 is what here? 92 degrees centigrade. So 92, don't write values, units. 92 minus theta naught 24 to e power minus k log minus kt. So log 17 by 14 t. 65 minus 24 equal to 92 minus 24. 92 minus 24 is what here? Just now we have calculated. It's 68 e power minus log. This minus will be sent to that side. It will become what it will become? So inverse of it. So it will be log plus log 14 by 17, and again it will come like that only into t. So here you will get what you will get. So it is into after getting to that side, it will become to the power 65 minus 24 is what here? 65 minus 24 is 31. Is it correct? No, 41. 41 equal to 68. So here it won't be cancelled out. So I am writing as it is e power log. This is into. After this is going to that side, as we use it this formula, by using the same formula, we'll get e power log 14 by 17 power t. So here it will be 41 by 68 equal to e power ln base to the base e is taken as ln. So here ln x equal to x. So by using this logarithmic formula, I am writing it here like this: 14 by 17 into power t. 14 by 17 power t. So here after solving this you will get the answer. So for solving these types of problems I will apply logarithmic on both sides. On both sides it will become log 41 by 68 equal to t log 14 by 17. So here it will be log 41 by 68 divided by log 14 by 17. By calculating it in the calculator you will get the answer. So I am opening the calculator. Here I am using FX991CW. So here I am taking log on the calculator first. Next log to the base e you should take, always to the base e for these types of problems. What problems? For the Newton's law of cooling or Newton's law of heating also. Shift plus 8. Shift plus 8. It's not working, right? So just left the thing is that only calculating it in the calculator of the time t. So yeah, this we should calculate in this calculator. So I am using this calculator FX991CW. So here in this you should do shift plus log. See this, shift plus log, shift plus log. So here it will be like this, log. So here to the base e. So shift plus e. You should press both at a time, not long pressing on the shift, and after that you should press on that number. You should press both the numbers at a time, single shot, like this. Then it will be getting. So ln e 41 divided by 68. Next whole bracket, you should keep whole bracket. Okay, next log 41 log 14 by 17. Just press ln. Ln is a representation of log e. So press log e and shift at a time. Log e, shift. At a time. So it will be ln. Next 14 divided by 17. So after that bracket, full bracket, 41 by 68 of ln and divided by log to the base e 14 by 17. It will be the answer. So calculate it by using execute. So you will be getting t equal to 2.605. You will take t equal to 2.6 seconds or minutes. The time is in minutes, so you will take it only in minutes. So 2.6 minutes. If you had converted it before in minutes to seconds, you can take the answer, you will get the answer in seconds. But you have taken it in seconds, 18 minutes, so you got the answer as in minutes. So this is the all about the Newton's law of cooling. This is the step-by-step procedure how to do it in an easiest way possible. So this is a very important problem repeated so many times in SE examinations in semester second of all branches, ODVC, ordinary differential equations and vector calculus. So it is very important chapter. So this is a step-by-step procedure. You can copy it from here. This is the at last answer, 2.6 t equal to. So this is the answer. So if you like the video, please subscribe to my channel, hit the like button, the bell icon and activate the notification bar. Thanks for watching, friends. Bye.